Alright, so let's look at this example in which we'll use trigonometry to help us solve this problem. You are watching a fireworks display where you are standing 290 feet behind the launch pad. The launch tubes are aimed directly away from you at an angle of 65 degrees with the ground. The angle of elevation for you to see the fireworks is 40 degrees. What is the height of the fireworks when they ignite? Alright, so this is definitely one where drawing helps out. So let's see here. So what happens is we have some launch tubes. There's our launch tube. And it launches a firework. And the firework explodes right here. Okay, there's the fireworks. And we know that the angle of elevation, or the angle that the launch tube makes with the ground, is 65 degrees. Now you're standing behind this 290 feet. And so here you are. And when you're looking at it, the angle of elevation is 40 degrees. So the question is, well, if I were to draw this down, what is the height? So how high is this? So this is a neat little problem. I mean, this has to do with fireworks, but it can be done with anything. I mean, if you ever see something in the sky and you want to know how high it is, you basically put something here and look at the angles of elevation, and you know the distance between you, and then you can, do this little trick to get that height. All right, so let's see how this would work. Now, one of the problems here is none of these are 90 degrees. So we can't use, for example, some kind of trig function to get that. I mean, we could figure out this angle and figure that out that angle, but without a right triangle, we don't have the information. So this is what I do when I have a problem like this. I'm going to go ahead and get the distance from here to here to be x. So that's from here to here. All right. And because the height is right above the ground, there is our right triangle. And so we're going to have two right triangles. We're going to have a small right triangle here, and then we're going to have a big right triangle here. So let's first look at this small right triangle. So relative to this 65 degrees, we have this side as the opposite and this side as the adjacent. And so that's tangent. So we know that the tangent of 65 degrees is the opposite over the adjacent. Right, now I'm going to look at this big triangle, and in this big triangle, here's 40 degrees, so that's opposite, and then the adjacent is this whole side here, so that's 290 plus x. So the tangent of 40 degrees is the opposite, h, over the adjacent, 290 plus x. All right, so in our study of, other algebra concepts, we now have this situation where notice that we have two unknowns, h and x, and we have two equations. So we can solve two equations, two unknowns. So there's probably a couple ways to do this. Substitution is going to probably work best in this case. So I'm going to multiply each side of this by x. So I'm going to have x times the tangent of 65 degrees equals h. And then here I'm going to multiply each side by 290 plus x. So we have 290 plus x times the tangent of 40 degrees equals h. And so quickly we have h over here and h over there, and so we can substitute one h into the other. So I'm going to substitute this one for that. And so we're going to have 290 plus x times the tangent of 40 degrees equals x times the tangent of 65 degrees. All right, now we have one equation, one unknown, so we can solve for x. We first have to isolate x, so I'm going to distribute that tangent. So we have 290 times the tangent of 40 degrees plus x times the tangent of 40 degrees equals x times the tangent of 65 degrees. Alrighty here. So I'm going to bring this x tangent of 40 to this side. So we have 290 times the tangent of 40 degrees equals x times the tangent of 65 degrees minus x times the tangent of 40 degrees. Alright, let me factor out an x. 290 times the tangent of 40 degrees equals x times the tangent of 65 degrees minus the tangent of 40 degrees. All right, now I just thought of something that lots of students want to do, but it's not allowed, and you'll see later on why it doesn't work. But they look at tangent of 65 and minus tangent of 40 and they think, well, isn't that just tangent of 25? And the answer is no, it is not. You cannot just subtract those like that. It's not the way trig functions work. And as we get further into our study of trigonometry, you'll see a little bit more why, but don't do that. That's bad. Okay, so now I'm going to divide by tangent of 65 minus tangent of 40. And so we end up with x equals 290 times the tangent of 40 degrees all over the tangent of 65 degrees minus the tangent of 40 degrees. All right, so now that's x, but we don't want x, we actually want h. So we got to think about, well, how do we get h? And luckily, we do have something up here for h. Notice that h is equal to x times the tangent of 65, so let's write that out. I have a little sheet of paper here. So h equals x times the tangent of 65 degrees. That was from this equation up here. And we know what x is. It's this whole thing right here. So why don't we substitute that x in for here? So we end up with h equals, so we have this big thing, 290 times the tangent of 40 degrees all over the tangent of 65 degrees minus the tangent of 40 degrees times the tangent of 65 degrees. Alrighty. Well, there you go. So now that we have what h is, we can finally go to our calculator. Notice I didn't get a value for x. I left it like this. You want to do all the work before you get to your calculator. So don't get an approximation for x yet. And now we can go ahead and do this. So remember to do this in steps. So let me start with this here. I'm going to do tangent of, well, first let me make sure I'm in degrees. I am. So we have the tangent of 65 minus the tangent of 40. All right. Now I'm going to take 290 times the tangent of 40 divided by that answer. And that's 186.40, and that's what x is. But then I'm going to multiply that by the tangent of 65. And we end up with an h is approximately 399.75 feet. So it's basically 400 feet above the ground. All right, so here's a nice little problem. It's a little tricky, you know, because what ends up happening is the way this is set up, you just can't get, you can't get a value. You can't get this, or you can't do other things. So you end up having to create another variable in here and creating two equations and two unknowns. But once you have that two equations, two unknowns, then it's not too bad to get to this part right here.